Okay, so first we should be familiar what a regular polygon is. It has all sides blank and all angles blank. What makes a polygon regular? Yeah, so all sides are congruent and all angles are congruent. Alright, you should be able to denote that or identify that by, you should be able to see tick marks to know that you have a regular polygon, unless they use words. Alright, so this is probably new for some of y'all. The parts to the polygon, the regular polygon. So that's the first thing you need to make sure. Because I'm not going to give you the parts. You're going to have to create them, but draw them and label them correctly. Alright, the first part, I hope you see like this arrow is pointing to right here to this dot. What does that represent? Yeah, it's the center. Okay, this regular polygon is circumscribed in the circle. And so if it's the center of the circle, it's also the center of the polygon. Now, this dashed line here, part would that be in the circle? Yeah, so in a regular polygon, I'm just going to add this on here. It is a radius in the circle, but in a regular polygon, it is also the hypotenuse. Show you where that right triangle will be created. Now this segment is probably new for you. And this is the most important segment because you have to know that part, know that measurement of that part to find the area of a regular polygon. This segment is called the epitope or epitope. Okay, and the epitope is a segment that goes from the center to the side of the regular polygon. And the epitope, if you look, will create, because it's perpendicular, it will create a right triangle with that radius, meaning the radius becomes the hypotenuse of the right triangle. Okay. So usually we use the lowercase a to show that is the epitope. So you got to know where each part is always going to be in the regular polygon based on its meaning. So the radius is the distance from the center to a vertice, or you wouldn't call it, some people like to look at it as the corner of the polygon. Vertices, your corners where the segments meet, where your sides meet. The epitope is the perpendicular distance. It always has to be perpendicular from the center to the side. And the epitope always bisects, this is very important when drawn, because you're going to have to draw them on your regular polygons. It always bisects the side to which it is drawn. So this epitope is bisecting that side into two congruent parts. So I can either look at the right triangle formed with the epitope and the radius, or I can look at the isosceles triangle. Okay? And this is going to help me understand something that occurs. So, I lost my tool. So, just for reference purposes, do y'all see? Do you see that we have not equilateral? Isosceles. Do you see it's isosceles because the two radii are congruent, so you have an isosceles triangle. Now this angle that I'm denoting in red, that is what we call the central angle. Okay. So how many triangles do you see? 6. Okay, so if I wanted to find the measure of one of those angles at the center, what would I have to do? Think about it. Take the 6 sides, divide by 360. 360 divided by 6 will give me the central angle, huh? So, what you are going to be expected to do is know the parts, come up with the measurements to each part. Okay. So, this is a formula. It is on your formula chart, but you have to know what each part in the formula is so you can derive it. So, area of a regular polygon is 1/2 times the apothem, that's the lowercase a, times p, which is the perimeter of the polygon. So a represents the apothem, p is the perimeter, s side to your polygon. Yes. Now, you're going to have to be familiar with sketching the apothem and creating the right triangle. So you're going to be given a regular polygon, but it might not be labeled for you. So to sketch it, you would need to start from the center of your polygon, draw the apothem. So the apothem has to be perpendicular, so that's the first part. So that would be your apothem. And then you also need to draw your radius to make the right triangle. So I know this is not drawn for you, so you need to draw it and make sure you know how to label the parts accordingly. Now, these first two that we're going to make sure you do before we leave is one is not drawn, one is drawn, but can you get the parts and plug it into the formula? So, solve the area for each regular polygon. What's the name of this first polygon we have here? Yeah, pentagon. How many sides does a pentagon have? 5. Okay, so we are going to draw from the center the apothem, and we're going to draw the radius to create the right triangle. So the apothem is just the perpendicular. Remember, it bisects the side when it is drawn, and then the radius goes from the vertices to the center. So there's your radius. Now, in this problem, they tell me my apothem is 7.2, so I'm going to go ahead and label it 7.2. It says the side S is 12, so one of my sides is 12. So I'm just going to plug in the parts. I know this is 7.2, the S is 12. Now we need the perimeter for the formula. So what is the perimeter? Yeah, 60. Okay, just the 12 times the 5. So now we're just going to plug it into the formula. 1/2 times the 7.2 times the 60 to get our area. Go ahead and calculate that. You should have a whole number answer. 216, yes, meters squared. Okay. Remember, you have to take half of the apothem times the perimeter. Alright, now, on this next example, it is drawn for you. Okay, your right triangle is drawn for you. But we still need to make sure we can plug in the parts and make it and relate it to the regular polygon. So, what name of this polygon? Yeah, octagon. There's 8 sides. Good. All right. The apothem. Which number is going to represent the apothem? Yeah, the 4.8. It's already given to you. Okay. The side 4. It's already labeled for you. The perimeter is 32. So now it's just a matter of plugging it into the formula to get the area. You will have a decimal answer here. 76 point what? Yes, good. Meters squared. Okay. Alright, so making sure you know where each parts and what they represent so you can plug it into the formula appropriately. So on the back, this is what more of what how you're gonna be tested though. Okay. So there are 4 steps that you need to memorize or basically apply to your problems dealing with regular polygons. Because I am not going to give you the side, or sometimes I won't give you the apothem, and you're going to have to come up with its measurement. So highlight the 4 steps. Let's talk about each step, and we're going to apply it to our practice problems. So the first step is to find the vertex angle in the right triangle. So you have to use this formula. You're going to be expected to memorize this formula. It's 1/2 times 360 divided by n. What do you think the n represents? Yeah, number of sides. Yeah, like if I didn't take half, it's finding the central angle. I didn't take half to find the interior vertex angle. Yeah. All right, they give the label. They're given and the degrees to the right triangle. Determine which trig function. You need to add this or which special right. Which special right triangle to use. Then you're going to substitute, once you get it all labeled and all calculated, you're going to substitute and solve for the area. So when we solve for the area, we're always going to end up using 1/2 times the asymptote times the perimeter, or half the product of the two. Okay? All right, so the key to this is being able to do the first step and drawing your right triangle. Okay? Because you have to make sure you draw this right triangle and get it labeled. So on number 3, we need to first get our right triangle drawn and understand that it bisects the side whenever you draw the asymptote. We need to come up with the angle up here. To do that, you're going to do that formula 1/2 times 360 divided by n. So, what is the measure of the angle, the vertex angle? What's our number of sides? Okay, so we're taking half of 360 divided by 6. So half of 60, right? Which is 30. So this angle up here is 30 degrees. I know you can barely see that, but that angle in the interior, the vertex angle, or the right triangle, is 30. Okay, so now, let's do some problem solving. If that's 30, yeah, this has to be 60, 30, 60, 90. The 6 represents what part in the right triangle? Hypotenuse. Okay, so if we do hypotenuse, then I can at least get to the small side. Okay, using my 30, 60, 90 rules. So what's the small side? Yeah, so that's 3. So if that's 3, this would be 3 over here too, right? So that tells me the side is 6, okay? Now, how do I get to the asymptote? I want to find its perpendicular distance from the center to the side. Oh, there's another way. It's a faster way. You're right. Pythagorean theorem would get me there. Think about it. If this is 6, this is 3, what would this be? Yeah, 3 square root of 3. Okay? Take the side, the short side, multiply by radical 3. That gives you asymptote. Now I know that my A is 3 root 3. But now I need to find my perimeter. Yeah, my perimeter is 36 because each side is 6. So now I can go straight to my area using the formula 1/2 times the times the perimeter. So 1/2 times 3 root 3 times 36. Okay. Order doesn't matter. I have some students who like to just say, I'm going to do 3 root 3 times 36, then divided by 2. Okay. We're not rounding. We should have an exact answer here. So, who could you take a half of? Yeah, the 36. That's a whole number. What's half of 36? Okay, so now basically I'm saying 18 times the 3 root 3. What would that give me? 18 times 3 root 3. Yeah, 54 root 3. Only the outside gets multiplied together. Okay? So my exact answer is 54 root 3. Now, same type of problem, same shape. The difference is I did not draw the asymptote. That's the error. 54 root 3 is the error. So on number 4, what are you going to have to draw and label? Yeah, the asymptote, you got to create. Yes, the radius with being the hypotenuse. All right. We know from the previous one that this vertex angle is 30, right? So we're going to still have a 30, 60, 90, right? What does the asymptote do to the side? The bisection. Okay, so what would this little part? That is 5. Okay, so if that's 5, could you get the radius? What would the radius be? Yep, it's 10. You just double the short leg because we already had the side here. And then what is the asymptote? Yeah, 5 root 3. Okay. Huh? Oh, I'm glad you saw that. Okay, does anyone see there's a pattern here? This was 6, and the hypotenuse was 6. This was 10, the hypotenuse is 10. Joseph, it is equal. That pattern only works with this shape, the hexagon. So that is a fact that you could use for a hexagon. Whenever you have a hexagon, if I know the side, it's going to be the same as the hypotenuse in the right triangle, and vice versa. Okay, but only in a hexagon. Yes, Austin? Depending on the shape. some shapes turn into a special right. If they don't, Austin, then you use trig to find the apothem. Okay? Alright, so we know A is 5 root 3. What's the perimeter? 60. Okay, so now we're going to do the area, which is 1/2 A times the bottom times the perimeter. So what's our area here? Yeah, 150 root 3. Yeah, there we go. All right. Okay. So do get familiar with the 30-60 happening with the hexagon and the side being congruent to the radius. And this is going to be totally different. We'll deal with these tomorrow. Homework check tomorrow. It's already been posted.